Hello everybody. In this video we're going to start thinking about why we haven't talked about the horizontal position. What I really mean is of a rider here. So we've talked about the vertical position of someone on the screamer for a while, but let's just rethink about this. So we're on the screamer again, our very first Ferris wheel. We know our radius is 100 feet and our center is on the ground, So if I'm looking at a Ferris wheel here, I have a circle first. Not too shabby. And I go like this, make my y-axis, my horizontal axis right here. Now, up to this point, we have thought about like, okay, given maybe 50 degrees right here, 50 degrees. I'm just gonna estimate that around here, 50 degrees. You guys are getting great at making a reference triangle, putting your line straight down, marking your right angle, and making this your reference triangle. You know that the radius of the screamer is 100 feet, so you label this, and we're trying to find this vertical position, this height here. And you guys have done this tons of times. You know that this angle, well, if this is 50 degrees, then this angle is also going to be 50 degrees. So we know this, and you know that you can solve for the vertical position by rocking a sine of 50 degrees is equal to x over 100 times 100 on both sides. And we have 100 times sine of 50 is equal to x. And if I wanted to calculate that, I take out my handy dandy phone right here and I go, calculator, what is 100 sine of 50 degrees, and I get around 76.6044. So x is equal to 76.6044 feet is equal to x. So that right here, that is our height. Another way of saying that, that is our vertical position. And another way of saying that, this is the y value of that point on the Ferris wheel. Now, here's the thing. We've never asked about the horizontal, so I'm going to take my green highlighter right here. The horizontal distance for 50 degrees is how much distance is it to the middle, to the y-axis right here. And that right here is just going to be this distance right here. So this right here is going to be our horizontal distance or position right here. And we can also call this our x value for that rider. How far away from the center on the x-axis is that 50 degree guy away? So I want to pop this triangle out right here, and I want to see if we can solve this. So I'm going to take this triangle, I'm just going to draw it like right down here. I'm going to draw the exact same triangle. Boom, and up, and to the here. Our radius is still 100 feet. Our angle is still 50 degrees. But instead of trying to solve for the vertical, we're now trying to solve for our horizontal. So here's your first pause moment here, guys. Instead of using sine right here, which one of our SOHCAHTOA trig ratios are we going to use here? Pause your video, please. And when you come back right here, well, we have our adjacent and we have our hypotenuse. So we know that we're going to use cosine right here. So cosine of 50 degrees is equal to x over 100. So when we multiply it by 100 on both sides, we have 100 cosine of 50 degrees is equal to our x. I don't know what that is off the top of my head. So I want to, unlock my phone and I want to show you 100 cosine of 50 degrees. That right here is 64.2787 feet. That right here, everybody, that is our horizontal position. That is our x value. Same idea right here. So let's think about this. If I just draw a generic Ferris wheel like the screamer, I'm going to draw it right over here. And I'm going to draw my y-axis and my x-axis. I'm going to kind of make a line around this so you know I'm not trying to mix you up right here, okay? Now, we have a horizontal position on our mind. So here's the thing. If I draw this triangle right here, let's say I'm going to go all the way to 110 degrees. 110 degrees. And let's say I want to find the horizontal position. I do the same thing. I still make my reference triangle. And I still make my right triangle sign right there. And instead of trying to solve for that vertical distance, I'm just going to highlight again. I'm trying to solve for this horizontal distance now. This one right there. And here's a question for you guys. This is another pause moment. Is this horizontal position, is this x value? Is this x value positive or negative? Pause your video. Think about this for 1 second. You're coming back right here. To the left of the y-axis is our negative x value. So this right here would have a negative x value, not a positive one. Now, what you're going to do right now is you're going to look at this document that you either printed out or you're looking at on your screen. This is what is on the Canvas page for today. What your job is to do is to try all of this front page right here. And then I want you to, after you've tried this entire front page, go to the stage 2 video, and then you can kind of see how you're doing. So for example, I'm just going to focus in so you can see. For example, 70 degrees is right, around here. Your first job is to draw that reference triangle again. I always like to make sure I know what side I'm solving for. The horizontal distance right here, that means we're going to solve for this side. Folks, go for it. When you're done with this whole front side, check out the stage 2 video. Thank you.